All right. Well, okay, I guess maybe we can phrase the question a little bit differently. How many independent node rule, I mean, you can write an infinite number of node rule equations, right? But how many independent node rule equations are there that can actually give you useful information, right? What node do we want to focus on? What particular useful node in this circuit would be the one that splits, right? Let's pick that spot, right? And so we know there that the current, let's see, the current electron current is going that way, right? So little I is going that way. So let's call, and again, I can sort of apply the node rule everywhere, and I know that along this branch of the circuit from the node rule that the current in this wire here has got to be equal to the current in this light bulb. So I'm just going to call this I1, okay? And it splits into two currents, right? That's got to be I2. And again, sort of another use of the node rule is again saying that the current here has got to be the current here. Okay, so the current through that light bulb is I2. And it's this current we'll call I3. It's the same as the current through this light bulb. So we end up getting I1 is equal to I2 plus I3. All right. And if I applied the node rule here, I would get the same relationship, just I2 plus I3 is equal to I1, okay, because the current I1 has got to be the same through a continuous branch, right? That's essentially another application of the current conservation, the node rule, okay? So maybe it was worded a little bit unclearly, but once we have a node rule equation, we can solve this system. Well, we've got to put this in terms of electric fields, right? So we have N A1 U E1 is equal to N A2 U E2. And I'm assuming that the N's and U's are the same for these light bulbs and just the area is different. Plus N A2 U, or excuse me, N A3 U E3. So there's an equation with three unknowns. Presumably we would have the other symbols. We'd have N, A, and U. There's an equation, or pick two of these, right? There's an equation and there's an equation. And so I'm not going to do it, but you could go through, just do a bunch of algebraic substitutions. It's just an algebra problem at this point, just going through substituting into a single equation so that you just have one unknown in a single equation, solving for it, and then plugging back in and getting a result. Okay, so you'll have a problem like this for homework, but this is the basic idea. You have to use the loop rule, but you also have to use the node rule in order to get enough independent equations to actually solve the system. And if you go into electrical engineering or some other circuits, take a circuits course, there'll be all sorts of more complex ways, different mathematical tricks of solving circuit problems, but they're all basically based on this. Okay, this is sort of the fundamental place where it's coming from. Okay,